In this next video, we're going to look at using generics in classes that we write ourselves. So this is essentially the way that we'll use generics throughout our course. So in this course, we're going to be writing a lot of classes that represent data structures like lists and queues and stacks. And in all of those classes, we're going to use generic type placeholders to say that yes, I'm writing a class that specify how a stack works, but you can use that stack to hold strings or to hold integers or to hold students or to hold whatever you want. So the way we do that again is through generics, is by that type parameter. So we're going to do this in writing our own class. We're going to do it with an example of a box. So this particular box, that class that we're going to write, a box can only hold one thing at a time. So it can basically hold one object, and we're going to keep track of that object, and we're also going to keep track of how many times that object has been replaced. So we're going to keep track of a count of how many different times you've changed out the item in that class, or in that box, okay? We're going to start by writing the class without generics, just so you can kind of, again, get a sense of what the box class is meant to do, and then we'll write the improved version, which uses generic. So I'm going to call this first class box R for box raw. This does not use generic typing. So we're just going to hold an object of type thing. An object of type object, right? Capital O object. So our box can hold anything. It can hold an integer, it can hold strings, it can hold students, JButtons, whatever you want. And then we're also going to have a thing count. So how many times you've put something in this box. So we're going to have one constructor where you send in the first thing, and we'll say, okay, the thing in our box gets that first thing, and the thing count is now 1 because you've put something in the box one time. Oops, of course, the class name is box R. So that's my constructor. So I'm writing this just like any other class. So I want to have those core components in there. I want to have my instance data variables. I want to have my constructor. Next up is getters and setters. And then I'll write a toString method. And I'm going to skip the equals method for now. No, actually, we'll write the equals method because then we can see how it changes with the generic version. So next up, getters and setters. So I'm going to have a getter. So we can, I'll say get the contents of the box. That just returns the thing. I'm not going to include a setter for the contents of the box because we're going to add a different method that allows the user to replace the item. So I'm just going to leave off a direct setter, okay? But I am going to include a getter for the thing count. And again, I'm not going to include a setter for thing count because I don't want someone to be able to directly set that number. That number should only be updated when someone replaces the contents of the box. Okay, I am going to have a toString, and I'm going to say that my text representation of my box is going to be just whatever the thing is, so the string version of that thing, plus I'm going to say what number item it is in the box. Okay, so it'll say, oops, not item count, but thing count. It'll say whatever the thing is plus what, this is item number, 4 or whatever it is. Now note that we're allowed to invoke toString on thing because thing is of type object, and the toString method comes from the object class. So we know that no matter what the real type is, actual runtime type is of thing, it's going to have a toString method, even if that means it's the original one inherited from object that just prints out the memory location. So here's our core components: instance data variables, constructor, getters, and setters. We decided not to include setters. Got the toString. Let's add our equals. Okay, so that's our method header for equals. And we can say, well, if other is an instance of box R, then we'll compare the two boxes. And if it's some other type, well, then I can tell you that they're not equal. Now, I'm going to specify that what makes two boxes equal are that they have the same thing inside them at the moment, and they also have the same count. So they've had things replaced the same number of times. Okay, you could think of other ways that make two boxes equal. Maybe you just want to say they're equal if they hold the same thing, even if there have been a different number of replacements. You could define that for your own class. So there's different ways. Remember, you get to specify what makes two boxes or two objects in general the same. But for this version, what I'm going to do is I'm going to again say that they have to have the same thing. So that means that first I have to casts. I'm getting ahead of myself here. So I've checked that the parameter is of type box R, but note that the compiler doesn't know that. The compiler still only knows that other is of type object. So if I want to be able to access the elements that make it a type box R, I have to cast it. Now this is safe to do this cast because I'm inside of my conditional. So I, as the programmer, know this is never going to give me a runtime error because I've already checked to make sure this is the appropriate type before I cast it. So you always want to do these two things together. The instance of is the check for you, the programmer, to make sure the object is the type you're casting it to, and then the actual cast is for the compiler to tell it to treat it that way. So these again should always kind of come together as a pair. So now that I've casted my parameter to type box R, I can test whether my current box has the same thing as my other box. So I can say if this thing equals other box R.thing, that means they have the same object inside the box. Okay, and again, I don't actually know what the equals method is for these things. It'll depend what the actual runtime type of thing is, right? And then I can say same count is going to be equal to whether the thing count equals other box R.thing count. Now notice again that here we use the equals method to compare objects, and we use double equal sign to compare integers. You can't invoke any method on a primitive, not equals, not any method, so we have to use double equals to compare integers, but almost always we want to use the equals method to compare objects. We don't want to use this because this tells us whether these two things are aliases, not whether they are logically or kind of meaningfully the same. So then for my equals method, I'm just going to return if this is both the same thing and the same count. Okay. Sorry, I forgot my S there. Okay, so here's my equals method to compare whether two boxes are the same. So I'm going to add one last method. These are kind of my core components that I would put inside of any class. And then I can go ahead and add methods that make sense just for that particular class. And of course, the one I want to add here is replace contents. So you can send me a new thing, and I will update the thing in the box. And I will also update the thing count. So this is how I replace the item that I'm holding in my box. Okay, so here's an example. This shouldn't look like anything new to you. This is just a regular class, doesn't use generics at all. Okay, so if we go over to our tester program here, we can create some of these objects. So let's say we wanted to create a numbers box. And let's say we wanted to start with the number 4 in our box. Again, we're allowed to send in the primitive value because this will be automatically boxed into, sorry, that's confusing to use box when our class is box, but the process is called auto boxing within Java, but it's the same thing as if we were to do that. Okay, so we could do that, and then we could say numbers box dot replace contents with the integer 5. But of course we could also say numbers dot box dot replace contents with a string. Okay, so there's no way for us to restrict at compile time or at runtime the elements that go into this box because there's no generic type. So this box can hold any object, and I can put any object in it. So even though as a programmer I really only want this numbers box to hold numbers, there's nothing that stops someone or myself from accidentally adding a string to it. Okay, so again, this is the kind of the downside of not using generics, is that it removes that compile time check. And then of course, if I were to try to get something out of it, let's say we hadn't made a mistake and put a string in there, but even if I wanted to get the current contents, I'd have to cast it, right? Because the compiler only knows that the numbers box holds object. So even though I, as the programmer, know I've been very careful, only put integers in, I have to cast it to an integer because that's all the compiler knows, is that it's an object, not an integer. And then of course, if I'd accidentally added a string, this is going to end up giving me a runtime error because, right, a runtime error because I've tried to cast a string to an integer. So these are all the downsides of writing this class without generics. So let's now update this class and let's make it much better by using a generic type parameter.